so here we are. So take a look at this stuff. First page, how do we feel? Dece? We feel all right? Okay. Remember, if you're not sure if like what you're doing makes any sense, I hope we can all plot points and use some reasoning. So for number 1, 2 comma 5 is 1, 2, 3, 4, 5. Right here, that's A. Always label your points. And B is 4, 3. So there's 2, there's 4, there's 1, 2, 3. There's B. Now again, if we take out good old Saddam and we draw our segment here, right? I bet you can figure out where the midpoint might be. Looks to be about here, yeah? If you need a protractor for tomorrow to have a straight edge, right? Get one. And so that should be the midpoint. So if we look, that's going to be 1, 2, 3 to the right. That's 3, comma, up 1, 2, 3, 4. 3, comma, 4 is what we should expect. Is that what you got for the midpoint? Good. Then your algebra was good. Algebra hard. You're going to make dumb mistakes, right? You're going to subtract when you're supposed to minus. God bless you. You're going to forget to square stuff, right? It's going to happen, right? So use geometry, the visual part, to make sure what you're doing makes sense, right? If you have a line segment here and they're like, find the midpoint, and you go to plot it, it's like, oh, there it is. You probably goofed, right? You probably goofed. All right, so that was the midpoint for that. To find the distance, well, if we look, again, thinking geometrically here, remember, distance formula is just Pythag. And Pythag tells us what the hypotenuse is. Well, the hypotenuse is this segment. That's what we want to measure, right? Well, if this leg is 2 in length and that leg is 2 in length, then we can check this with Pythag. 2 squared plus the other 2 squared, and then it's all rooted, right? And that gets us C. And C is the length of this segment, yeah? So we get 2 squared plus 2 squared, which is 8, right? So your answer should have been root 8 for the distance. Is that what you got? Wonderful. That's great. Now you can check that with all of these. Okay. Same thing. Some are going to be easier to do than others. Let's do that really quickly. I know I keep forgetting to say trade and grade, but trade and grade? Or do you want to just hang on to it and go from there? Can we all be honest? It's homework, like you could have cheated beforehand. Why didn't you do that, right? Anybody need pens to grade? 1 for you. Oh, sorry, I'm sorry. 1 for you. 1 for you. I have a great shot. Good morning. I'm sorry. I like your haircut. I get excited sometimes. I need 3 back. 3's back. Yeah, watch out. I will take this opportunity to take you out, okay? It was bad when I used to give out pencils this way. You know what I mean? They don't have caps. Danger, danger, danger. All right, so again, just to be clear about the directions, plot them, draw a line segment. I'm giving you a point to draw the line segment on the quiz tomorrow. So you better draw the line segment, okay? Like I'm easy pitch, hit it right, and people miss. Do what it says. That's why I underlined it. Find the midpoint of the distance. We did that. Plot the midpoint after you're done. That's the check your work part, right? Cool. So number 2, let's do that one geometrically as well. So we have -2, 1, 2, 3, that's A. And then we've got -4, 1, 2, 3, 4, 0, that's B. If we take out Saddam, here we go, our ruler. Yes. All right, so it looks like the midpoint's going to be somewhere around here. So it's going to be 3 to the left and then 1.5 up is what it looks like. And again, is that what you got? Okay, good. Then we can say that's good. And then 1.5 up is just, yep, 3 halves, right? 1.5 is just 3 halves, right? 1 half, 2 halves, 3 halves. That's 1.5. So that's the midpoint. For the distance, we can do this. It looks like it's 3 here and 2 here. So we have 3 squared plus 2 squared. Well, 3 squared is 9, 2 squared is 4, so what do we get? 13, right? But we remember we have to root it, because that gets us C. 13 is C squared, right? We want to find C, that's the length. So root 13, how you feeling? Dece, wonderful, excellent. A is 0, 0. Let me scoot this up. I really need to move this microphone since it's not even on, because my audio interface is crapping out on me. All right, get out of the way, pens. Pens. All right. A is at 0, 0. That's the origin. And B is at -4. 1, 2, 3, 4. Up 1, 2, 3, 4. There it is. There's B. We take out Saddam. We draw our line as best as we can. As best as we can. That's what killed my grandfather. All right, so. Looks like there. -2, 2. Negative 2, 2? Is that what you got? Okay, cool. I'll trust you on that. That's the midpoint. And now we do Pythag. Looks like 4 here and 4 there, right? So we have 4 squared, which is a fun game to play outside, and 4 squared, which is a fun game to play outside. 16 and 16 is what we get. We root that. It's going to be root 13. Or, I'm sorry, root 32. Which sounds like a fun place to drive. Questions, comments, concerns, other than about my grandfather and me? Okay. Did you know asbestos is legal again to build with? Because, like, why not, right? Hi.
Oh. I had it flipped, but I still got the same answer.
What do you mean flipped?
So, like, just take that triangle and flip it upside down.
Oh, yeah. So check it out, guys. There's 2 ways to draw this triangle, right? You could also draw the triangle like this, right?
Yeah.
And notice it's 4 and 4. That's the magic of triangles, right? And it makes sense because really what's happening here is when we do it this way, we're asking what's the distance between B going to A, right? Maybe that's how you look at it. And this one's asking what's about the distance from A to B. Well, in Euclidean geometry, which is most of geometry, if you travel from one point to another, it should be the same distance as going backwards, right? So yeah, it works either way. You have a choice of how to draw your triangles, okay? Make sure they're right. Okay, so the back side says graph each pair of coordinates and connect them to form a line segment. We're going to do that. So 3, 0 is A, and then 0, negative 6 is B. 1, 2, 3, 4, 5, 6. Did everybody plot those points correctly? Okay, good. You don't want to screw that up. And that one's A, and that one's B. This is important. Okay, always label your points. We're going to take out Saddam. We're going to do this. Okay. And now we're not looking for the midpoint, right? We're looking for a ratio of 1 to 2. Okay, so our M and our N for our formula, here's M, 1, and N is 2. For section formula, 1 and 2 are going to be our M and our N. Now, remember, when we talk ratios, it's like dividing up cards. In total, 1 plus 2 is 3, so we have 3 cards to deal. Person A is going to get 1 card, person B is going to get 2 cards, and what does that mean? Well, that means 1/3 of the cards are going here, and 2/3 are going there. Just so you know. So between A and B, we want 1/3 of the way between them. So we're looking like right here is my estimate. That looks about 1/3, right? See how this part is twice as big as this part? So we have 1/3 there and then 2/3 there. So it looks like that our point P, not the midpoint, right, should be 2, negative 2. Is that what you got? Okay, cool. So we can check it visually. Sometimes you can't do that, right? Sometimes the points are really gross, right? When you divide stuff strangely, God bless you, you might get like a really irrational, well, I guess you wouldn't get an irrational number, but you get something really crazy. So the way we can check that, I'm going to do the formula for this one and not the rest, okay? So here's what the formula is. You need this guy and notice that y2 and x2 come first. Before, when we were doing midpoint, it didn't matter because the distance between A and B is going to be the same when you do the midpoint, right? And when we do distance formula, it doesn't matter whether you're going from A to B or B to A when you're measuring the distance, right? But here, order does matter because 1/3 of the way from A is different than 1/3 of the way from B. See how we get 2 different answers? So if you want starting with A, moving 1/3, which is what they're saying, right? Starting with A and moving to 1/3, okay, you need to make sure that x2 and y2 are first, which is your B's, right? Here's x2, y2. Here's x1, y1. That's important. You can't screw those up, okay? y2 and x2 have to come first. Why do I do it that way? Other people do x1 and x2 first, but I feel like most formulas, when they're presented, do it this way. 1. And 2, that means that M and N are in alphabetical order, which I think is better. I don't know. That's just my call. Okay? If you do flip x1 and x2, then N and M have to be flipped as well. Okay? See how N always goes with x1? Right. And then on the bottom, we have N and M being added together. So this is really just midpoint formula, except instead of the ratio being 1 to 1, that's midpoint, right? You get 1, everybody gets half, right? Okay? Now our ratio is different, so we have to plug those numbers in. When we do midpoint formula, we're plugging in 1 for M and N, which makes M and N go away in the top, and in the bottom, when we add them up, we get 2, right? That's our midpoint formula. So we've been using it the whole time. Now we're going to plug in 1 and 2 here. So I plug in 1 wherever I see an M, I should say. I'm going to have x2 and x1 there. Oops, we're going to fill in y2. And I also have my ends, which in this case is 2, right? So here's where my 2's go. And now we plug in x1, y1, all that stuff. So first off is x2, which is 0 problem, right? And then we do the other x, 3. Do not plug in x2 and y2 here. Remember, it's the average of the x's, average of the y's. And it still is, right? We're going to average these out. We have 1 x here and 2 x's there. So that's 3 x's. We divide by 3 because there's 3 total parts, okay? So it's still the average. We're adding, and it's going to be both the x values, x2 first. Here we're averaging the y's, y2 first. That's -6 in this problem and 0. And what's nice about this problem, if you notice, is that 1 times 0 goes away and 2 times 0 goes away. Right? So we get 6 divided by 3, which is 2. And then we get -6 divided by 3, which is -2. And that's what we said we'd find, right? So that is going to be our point. How do you feel? Okay. For number 5, what's m and n? What is it? Come on. What's going to be our m and our n? 2 and 3. Very good, right? So when we do this, we're going to have a 2 here, because that's m. And we're going to have a 3 here, because that's n. We're adding and dividing because we're finding an average. And this is a coordinate, and that's going to get us p. x1, y1, x2, y2. Let's plot these points and see if we can figure it out without having to do the formula. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's A. And then we have B, which is 0, 0 at the origin. Hooray. Take out Saddam. And we draw our segment, which you get a point for. And we want to find 2 versus 3. Well, in total, that's 5, right? 2 and 3 adds 5, so we have 2/5 versus 3/5 here is what we're talking. Okay, 2/5 of the way looks like this point right here, right? We've got 1 diagonal, 2 diagonals, 3 diagonals, 4 diagonals, 5 diagonals that are all congruent. They're all the same thing. So it should be right there. So what's our answer? It should be 2, -2 again. Is that what you got? No? Did I goof it? Did I draw incorrectly? 3, -3. 3, -3. Oh, right here. My bad. My bad. My bad. At least I think so. Actually, no, you might be wrong. I might be right. Oh, no, A's down here. That's what I messed up. Always label your points. So notice I went from here 2/5, but we're supposed to go from A 2/5. That makes sense. My bad. All right, so now we're going to plug in our stuff. We've got we got 0 here and 5 there. Remember, x2 comes first, and we have our y values, 0 and -5 here. And once again, those zeros make things go away, which makes our life a lot easier. It's not always going to be that way, but you're welcome. We get 15 divided by 5, which is 3. And we get -15 divided by 5, which is -3. Boom, done, right there. How you feeling? Okay. Number 6. I'm not going to do number 6. I'm just going to, yes?
Can I go to the bathroom?
Yes, please, just not in here. All right. I'm not going to do number 6, but I am going to show you how to get the ratio, right? Because that's the difference between all the others, right? So they give you as a fraction. They say, I want it 4/7 of the way between something, which I feel like is how most people talk, right? Like halfway between things, a third between things. So we need to know how to convert this to a ratio because m and n are always in ratio form. Well, if we have 4/7, that means we have 7 total cards. And one person's going to get 4/7, right? Well, that's 4 of them. That's 4, right? And the other person's going to get 3. So what's our ratio? 4 to 3. Right. Remember, we're talking about ratio of the parts. Well, you get 4 of the parts. The other person gets 3 of the parts. The total is the bottom. So our ratio is 4 to 3. So you should eat 4 and 3 for m and n. Okay? Now let's try and figure this out geometrically. 0, -7 is here. 1, 2, 3, 4, 5, 6, 7. And that's A. Again, label your point so you don't make a mistake like I did. Okay? And then 7, 0. 1, 2, 3, 4, 5, 6, 7 is B. We connect them. And what happens? So this is another nice one. See how the diagonals are all the same and they hit on the corner? So I can estimate. So starting at A, we want to go 4/7 of the way. Well, here's 1, 2, 3, 4, 5, 6, 7. So I need to go 4. 1, 2, 3, 4. Point should be there. So if you did your math right, it should be 1, 2, 3, 4 down -3. Is that what you got? Bueno, awesome. All right, so all right, all wrong. Okay? If you love your grade, turn it in. If you don't, go fix it. Get it to me tomorrow, okay? I'm sorry that it's such a quick turnaround, but sometimes we have to do a moron day, which is what we did yesterday. Remember, moron days don't mean you're morons. It means we're doing more on the last lesson. M-O-R-E-O-N. Okay? I can say that because old Miss Fraley used to say that. And she is an upright, righteous woman. And so am I guess. All right. Nope, you don't have to, but if you want to, that would make sense, right? It'd probably be easier for you. There's not a lot of room. You could also do it on a separate sheet of paper if you want to do corrections. I got one back. Okay, can I see it? I got two back. I should have one more pen that I need to get back. So this one right here. 15 divided by 3 is that, and then, oh, that shouldn't be a 2. Or no. Remember, y2 comes first, and then y1. So your y2 is 0, and your y1 is -5. Do you see how that goes away? And so now you've got the right answer. Thanks for asking. I need one more pen, I think. Who has it? I hit your face, Luke! Pen. Nice. Okay, cool. So now we're going to get into the review guide. Here is your review packet. Remember, this is not for a grade, so when you see how thick it is, right, thick with 3 C's, don't freak out. We're body positive here, right? This will be something that you have to complete if you bomb the quiz and want to retake, right? Or you have to have a retake if you bomb it that bad, okay? So there's so many reasons why you should do the whole thing, right? It's going to help prepare you for tomorrow. This is going to be very similar to your quiz, right? But it also gives you a head start on that retake if you do bomb it in the event, right? This is quiz number 2 of the year.
It's not even that thick.
No, it's not. I give you guys a lot of room to do work, so like when it's like multiple pages, you shouldn't freak out. How many questions total are on here?
9.
9 questions, right? Come on. Now, do they have multiple parts? Oh, you betcha, right? So I'm trying to save on paper. Instead of asking 100 questions all individually, I ask them all at once. Like number 1, it says find the distance, find the point that divides the segment by the given ratio or fraction, show all your work, and check to make sure your answers make sense given the graph. Okay? So there's some stuff there. Jenna. What's up, Jenna? I'm so happy to see you, Jenna. Jenna, if everybody else in here are planets, you are the sun. You are the sunshine for our class. You keep us all together, okay? All right, so number 1, they give you this segment, which should look really familiar because I stole it from one of your homeworks. I just repurposed it, okay? So what they're doing here is they're saying a 1-to-1 ratio. What does 1-to-1 ratio look like as a fraction? Half and half, right? We have 2 total parts, and 1 to this guy and 1 to that guy. Another way to think of it is, if I'm dealing in a 1-to-1 ratio, right? Again, why do I keep putting these cards away? If I deal in a 1-to-1 ratio, you get 1 card, you get 1 card, you get 1 card, you get 1 card, right? If I keep dealing, we're going to end up with half and half, right? So that's what a 1-to-1 ratio is. So really, do we need to use section formula? No, we can just use midpoint. Because midpoint is section formula. It's just when you plug in 1s for m and n. And we know midpoint formula. Midpoint formula is the average of the what? X's, right? Because it's a coordinate. X's come first. And I always write x2 first. That way I'm good to go for section formula. Just get in the habit of writing x2 and y2 first. Okay? It's the average of them. And here, there are 2 pieces each, right? M and n 1. And so when we do this, right? Here's A, I'll say, 1, 2, 3, 4, -4 down 1. I've realized a fatal flaw in my plan here. -1, 1, 2, 3, 4. Okay. Depending on which one you call A, which one you call B, right? Your answer might be different for some of these, which is okay. Okay. I should have labeled these. So I'm going to call that one A and that one B, which means this is my x1, y1, and this is my x2, y2. And when we fill this out, M is going to equal the average of those x's, comma, the average of those y's. Well, we start with x2. x2 is -1, and then we're going to add on x1. In this case, x1 is -4. So I wrap that in parentheses. y2 is 4. And we're going to add on y1, which in this case is negative 1 wrapped in parentheses because it's negative, right? And so what do we get? M is going to equal negative 5 over 2, comma, 3 over 2. Is that okay? Sure. Right? Let's see if that makes sense given our graph. Negative 5 comma 2, over 2. So that's negative 5 halves. So starting at 0, let's move 5 halves to the left. Let's count by halves. Here we go. 1 half, 2 halves, 3 halves, 4 halves, 5 halves. So there we are horizontally. And then how far do we have to go up? 3 halves. So there's 1, 2 halves, and then 1 more. Does that look like the midpoint to you? Yeah, we nailed it. It's all good. Again, check your work there. It says find the distance as well, so don't forget that. So there's a couple ways to do it. I want you to be able to do both for the quiz tomorrow, both the distance formula and the Pythagorean theorem. So if you look, we have a right triangle here of 3 for one leg and 1, 2, 3, 4, 5 on the other leg. So we have 9 after we square the 3 and 25 after we square the 5. When we add them together and then root, 9 and 25 makes 34, so we have root 34. Or route 34, I suppose you could say, which is a road that you can drive in Sandwich, Illinois, my hometown. So there's the distance. Again, could we have gotten this by using distance formula? Sure, right? We would have plugged in our numbers. We would have gotten a distance of 3. We'd square it, do all that stuff, right? We'd end up with the same dumb crap. Number 2 is a 1 to 3 ratio. So for number 2, if I deal 1 card to you and 3 cards to the other person, how much of the deck did the person with 1 card get? A quarter, right? So really what we're talking is a quarter versus 3/4. Now, do I need to know that to be able to solve the problem? No, but it helps to check my work, right? So let's plot. We have our points. A quarter of the way. Let's say here's A and here's B again. So a quarter of the way, well, that looks like here, right? So that should be where P is. So our answer should be 1, 2, 3, 4 to the left and down 3. Oh, no, down 4. Down 4. I miscounted. So negative 4, negative 4. Again, quadrant 3 is double negatives, right? So that should be our answer. Let's check it out. Oh, not mid. This time it's P. So now we're going to use section formula, right? What are we going to divide by? What's M plus N? 4, right? That makes sense, right? Because we're finding a quarter of the way. Okay? So that means we should have our x's first, x2 comes first. Our y's second, y2 comes first. And for m and n, we have 1 for m. So 1 here and here. And n is 3. So 3 here and here. Now we can plug in our x's. Well, 1 is just going to be, times 1. That's going to be whatever it is. And then we have 3 times whatever x1 is. Again, 1 times y2 is just y2, so I leave a space for it, and 3 times whatever y1 is. Now let's go plug them in. So if I plug them in, x2 comes first. So our x2 is going to be this guy down here. Let's write in our coordinates. That's negative 5, comma, negative 5. x1, y1. B is negative 1, negative 1. That's x2, y2. So x2 comes first. That's negative 1. x1 comes next. That's negative 5. This next one, we've got y2 first, which is negative 1. And then y next. y1 next is negative 5. So what do we get here? Negative 1 plus 3 times negative 5. 3 times negative 5 is what? Negative 15 minus another one, we get negative 16 over 4. Here we get the same thing, right? See how they're identical? So we're going to get negative 16 over 4 as well. Now, maybe you circle that. That's fine. I won't take off any points. But there is a simpler version. Negative 4, negative 4. And by simpler, we mean a more recognizable version, right? Everybody knows what negative 4 is for the most part. That negative 16 over 4 is just a little bit more obtuse. And I mean that in the non-geometrical sense. Turn the page. Okay? We won't have time to do all of them. So here's what we're going to do. We're going to skip number 3. Why am I skipping number 3? Why? Why is it easy? It's 1 to 1, right? 1 to 1 is midpoint. That's not too bad. Right? If you can do the front side, you can do that one. Number 4 is 2 to 3. Number 5 is they give you 2/5. So how about we do number 5 so we can practice converting from fraction to ratio? Is that okay? Jenna, what say you? Is this okay? Okay, good. Jenna's okay with it, so we're going to do it. Number 5, everybody, on page 3. So the directions from the previous page say graph each pair of coordinates and connect them to form a line segment. So you better do that. So A and B, A is -4, 2. 1, 2, 3, 4, up 2. That's A. And then B is 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then we connect them to form a line segment. Okay, A and B, don't goof them. So notice that this is x1, y1, and this is x2, y2. So now that ratio, right, we need to get a ratio, because m and n are always expressed as a ratio, not a fraction, okay? So in order to get it into a ratio form, we have to think, well, 2/5 of the cards. That means you're getting 2 and you're getting 3, right? So it's a 2 to 3 ratio for our m and n. You smell what I'm stepping in? Yeah? All right. So now, 2/5 versus 3/5 is what we're talking. So it looks like there's a fifth, there's a fifth, there's a fifth, there's a fifth, there's a fifth. So 2/5 of the way from A should be here. That's going to be my guess, okay? So our point should be 0, 1, 2, 3, 4, right? Now let's check that with section formula. So m and n are 2 and 3. So that means what are we dividing by? If m and n are 2 and 3, what do we divide by? 5, right? We add them up. Or you can just look at the bottom of this denominator, right? We need to divide it up into fifths. 2, m comes first in the alphabet, right? So m comes first, and then there's n. And of course we're adding because we're still finding the average, right? Then we have x2, x1, y2, y1. Well, in this problem, if A is where we're starting, x1, y1, right? x2 must be 6. x1 must be -4. Again, your x's go here. Not x and y, but your x's. Our y's go here, starting with y2, so 7 and 2. So now we've got 12 plus a -12. What's that? 0 over 5? 0. Which is what we expected, right? It's okay to divide things by, 0 by 5 or whatever. That's okay, it's just 0. Then we get 14 plus 6, which is 20. 20 divided by 5? 4. Nailed it. Now, are we done with this problem? Look at the directions.
You have to find the distance.
Find the distance. We already plotted the point because we got that correct. So now we need to find the distance between A and B. Remember, distance is Pythag. You don't have to memorize it. Memorize it, okay? This is Pythag. I can also write Pythag like this, right? Where C is already solved. Well, what is A? Well, A is the distance horizontally. Which variable deals with horizontal? X. And we said distance, right? And distance is subtraction. So we're going to subtract our x's, starting with x2 first, just so we get in the habit of always doing the second one first. It's good for section formula. And then y2 first. So we have the distance between the x's squared, otherwise known as a, because a is the distance between the x's, right? And we have the distance between the y's, also known as b, squared. It's just Pythag. The only thing you have to remember is this part right here. Everything else you get out of Pythag, and I hope you have Pythag memorized. The distance between the x's, because it's distance formula, and the distance between the y's, distance formula. Distance is subtraction. So now we plug our stuff in. x2 is, in this problem, 6, and that's going to be minus x1, which in this problem is -4. And all of that is squared. Then we have a plus sign, because it's Pythag, right? Of course we add in the middle. Pythag is a squared plus b squared. Our y2 for this problem is 7. Oh, I'm sorry. Tell me that you see better. and then 2 for y1. And again, all of that's going to get squared, and that's going to equal c after we root it. Don't forget the root. Remember, otherwise it gives us c squared. Okay, so 6 minus a negative 4. Well, that's 6 plus 4. That's 10. So we have 10 squared. Plus, what's 7 minus 2? 5. So we have 5 squared. So that's a plus 25, right? So we get 125, the root of that, equals c. Is 125 a perfect root? No. Think about it. 10 squared is 100, right? 11 squared is 121. 12 squared is 144. So we skipped 125, didn't we? So it must be an irrational root. So we just leave it like this. And even if it was, like if that was root 144 and you didn't know that it needed to be 12, that's fine. I want to take off. Yeah?
Can we do it like we did on the front and then build it a triangle and then count the boxes?
For the section part of it? Yeah, I can do that. So check it. Is it oh, the distance. Right. Sorry, I don't know why I didn't think that immediately. So if we draw the triangle, assuming you plotted your points correctly, don't screw that up, right? Because otherwise these numbers will be off, right? Looks like we have 1, 2, 3, 4, 5 here, which is what we expected, right? That's what we got. And then our horizontal distance was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is also what we expected, right? After we subtracted, we found the distance. It's 10. After we subtracted, we found the distance. It was 5, right? But we can do it visually as well. So that means we have 10 squared plus 5 squared. I think at this point I could probably stop because we've already done 10 squared plus 5 squared rooted. That's 125 rooted, which is what we expected. Okay. So I'm going to leave number 6 for you. That way you can practice converting. Okay. This is the quiz, guys. Oh, no, it's not. We've got one more page, the backside. Ah, remember these guys? Yeah. All right, so let's take a look at number 8 because it's definitely the hardest one. And it's hard because it has a fraction in it. Now, remember, what they're saying here is they want you to find the other endpoint. We don't know endpoint number 2. We do know one of the endpoints, -2, -3. I'm going to put that here. Kind of draw a little diagram. That's endpoint number 1. And then our midpoint, not the endpoint, but the midpoint is at 3/2, 3. And so our endpoint number 2 is over here, and we don't know what that is. That's what we're looking for. So we're going to use midpoint formula to solve. Normally, we plug these two numbers in, right, these two coordinates, and it pops out the midpoint. So instead of popping out the midpoint, we know what the midpoint is. It's 3/2, 3. And that's going to equal the midpoint formula. What's our midpoint formula? What's the midpoint formula? The average of the x's, average of the y's. And when we're doing midpoint, we divide by 2, right? Because there's 2 different points that we're dealing with here. 2 different x's, 2 different y's. And if we're averaging, do we add or subtract? We add, right? That's the whole reason I make you say it that way. All right, so x1 and y1 are over here, right? And our x2 and y2 are what we're looking for. Normally, that's what we plug in, right? But we don't know this. So for x2, we don't know, so I'm just going to write x2. And y2, we don't know, so I'm just going to write y2. You'll notice that since we're plugging in numbers for x1 and y1, you don't need to write the x sub 2. You can just write x, because there's only going to be one x in this problem. But whatever. x1 is -2, so that goes here. And y1 is -3, so that goes here. And now we see x and y. And here's the logic, kids. This is a coordinate, right? So it's something in the x side and something in the y side. The x side here should be equal to the x side there, right? Whatever this is, when you plug in all your stuff and you know what this is and you plug it all in, you should get 3/2. And then over here, the y part should be equal to the y part. So if that's true, let's write that down. x2 plus -2 over 2 should equal 3/2, right? Now, if you're clever, you'll notice that, look, the 2's are both the same on the bottom. So the top must equal 3, right? So you can just set that up and solve for 3. But if you're not clever, we can do some math. So how do we get rid of division, right? That's probably the first thing we should do is get rid of that division. We multiply, right? So when we multiply, we're left with just the top And when we multiply over here, what's 3 divided by 2 and then times 2? Yeah, right? If we divide 3 by 2 and then times it by 2, it's like we just didn't do anything to the 3, right? So that was convenient. See how I told you you could just set the top equal to 3? Right. So now we're here. We have plus a negative 2. So that's really just minus 2. So when I move that over, I do the opposite. What's the opposite of minus 2? I add 2. So x2 is going to equal 5. So our coordinate for our point, our endpoint 1, or endpoint 2, I should say, 5 is going to be the x value. Now we need to go find the y value. How do we do that? Yeah, basically the same thing. Take this bunch of junk over here, and it should equal 3, right? So I'm going to write that. 3 equals y2 plus negative 3 over 2. What's the first thing we do to make a better world? We get rid of the division. And how do we do that? We multiply. So we multiply and we get 6 over here. And that's going to be a minus 3, yeah. And now to get y2 on its own, which is our whole goal, is we add 3 to both sides. So we get 9 equals y2. So that mystery endpoint is at 5, 9, which is slightly taller than I am. Questions? Try it on your own. The rest of the class is yours. It's not much, but it is yours. Work together. It's not about what you do, but it's who you do it with. Been saying that one for years. All right. You have questions, ask them.